In this segment, we're going to look at landfill gas and biogas, how they're similar and how they're different, and what that means for downstream treatment processes. So both landfill gas and biogas are formed from the same reaction. So we start with organic compounds. So this is either, food waste or yard waste we're putting into a digester, or all the organic stuff that just happens to be in our mixed waste when it goes into the landfill. It's going to go through all the steps of anaerobic digestion, hydrolysis, acidogenesis, acetogenesis, methanogenesis, and produce finally that methane and carbon dioxide that we find in biogas. 80 is in our nice purpose-built reactor that we want to have that biogas being produced in. Landfill, it's kind of just an accident. We didn't do any collection in the beginning. Now in a lot of jurisdictions, we mandate trying to collect that, but it's always harder to collect it from a landfill, which is just kind of surrounded with soil and maybe some engineered liners and covers and things like that, than connecting it from a tank where we can see all the edges and get at them easily and test them and things like that. And that leads to differences in the quality of the gas that's recovered from each. So that's why we have two terms, landfill gas and biogas. It's really the same stuff from the same reaction, but because of where it comes from, it has a different enough quality that we'll call it different things. So this table on screen summarizes some of the main differences. So the two columns on the left are for AD. So the leftmost one is from source separated organics. And then, as I mentioned in the AD unit, AD has been applied to wastewater sludge for a lot longer. So that's kind of what wastewater sludge looks like. And you can imagine if you did co-digestion, it'd be somewhere between the two. And then on the far right is what landfill gas looks like. So just looking at the very top line, at the methane line, you can see that landfill gas is a little bit lower in methane. It's a little bit lower in carbon dioxide. But if you go down to our oxygen and nitrogen, then it's a little bit higher than the anaerobic digestion options. Sulfide varies across them based on what the material going into that is. And then just for the biological methane potential of the material itself, you can see that landfill and AD are kind of around the same range. So if you've got a landfill with a lot of organic waste going into it, it's going to be just like an anaerobic digester with a lot of contamination in it. If you've got a better diversion system and you don't have as much organics going in, then it's going to be towards the lower end. So to actually get our gas from our anaerobic digester, it's pretty easy. This is a plant that we looked at earlier when we were studying anaerobic digestion. And you can see on the tops of the domes of the digesters in the sludge storage tank, there's these big hoses coming down. So you can literally just pipe the gas out of the headspace of your reactors. There's not too much leakage from these systems. It's really easy to recover it compared to a landfill. So a landfill, and we're going to talk about this in detail when we get to the landfills unit, but just to help you understand those differences between landfill gas and biogas. We don't have a nice rigid tank wall, airtight, tested according to the gas code, all this stuff. We have it covered in most cases just with clay and soil. In some jurisdictions, you might actually have plastic systems that are welded all the way around and stuff like that, but not necessarily. And instead of just having a pipe into an open headspace of gas, we're actually trying to pull it out of this mixed matrix of waste and pore space and liquid inside the waste. We don't have a nice free area of gas on top to just pipe it easily off of. And that's accomplished with either vertical wells or horizontal collection trenches, which just open up spaces in our massive waste and apply a vacuum to draw gas toward that well or trench rather than let it go out into the atmosphere. And these systems are never 100% effective. We usually use a number around 70% when we're modeling them. So a big chunk gets out, but we are able to capture a lot of it with these systems if they're designed properly. So if you think about a water well, it has like a cone of influence where it's able to pull in water and it gets depressed in the local area around the well. You have the same kind of thing happening with a gas well. There's a certain area of influence around the well that it can pull gas in from. And outside of that, it's just too far. You don't really feel the vacuum if you're out there, and you'd need another well to pull that gas in. So a well-balanced landfill gas system will have each well or trench having kind of a radius of influence that intersects with the next well or trench. So you have good coverage through all the waste. And we're going to deal with this more when we get into landfills. In the picture here, I've drawn a dotted line just to show kind of what a good sphere of influence around that would be. Over time, we know that our waste is going to produce less and less and less waste. This is the modeling we're doing in lab 1. So if we keep this same amount of air coming into the system, but there's less gas being produced over time, what's going to happen is that sphere of influence is going to grow. So now we're pulling too hard for the amount of gas that we're producing, and we're actually going to stop pulling from the waste and start pulling from the air. So this oxygen and nitrogen coming in from the air is exactly the reason that we have these higher numbers for oxygen and nitrogen in the landfill gas, because it's really hard to find that balance. You want to have this system where you're maximizing the amount of gas collected from the waste, but you don't want to be collecting too much. So to find that balance is kind of an active activity called well field balancing. This is just an example of the wellhead on top of those wells, and they're equipped with different devices for measuring and adjusting the flow. And visiting the wells on a regular basis and adjusting the flow based on the gas quality is important for making sure that the landfill is capturing as much gas as possible without drawing air into the landfill. And we'll talk about this all in great detail in the landfill gas unit, but just to show you where that difference arises between our landfill gas and our biogas, it's much trickier to collect gas from a big landfill through all these wells and trenches than it is to pipe it out of the headspace of an anaerobic digestion reactor.